Good day and welcome back to Tech Tips, Fixes and More. My name is Ron and this is part 2 of our Bose L1 stick PA system repair. In part 1 we got a start on repairing this PA system that belonged to a friend of mine, and the PA system was not functioning at all. Now, we were fortunate that we were able to find information from a person online who had done a number of these types of repairs before. And he had repaired at least 7 of them. He had pictures, he had schematics, he had testimonials from other people who had repaired these. And so this was all very helpful. And so in the last video, what we did was we basically opened the thing up, did some tests, determined that yes, the auxiliary power supply was faulty, and narrowed it down to at least one component. And at that point, we decided to order up that component and a few others that Lens Projects had suggested were common parts that failed. And so I ordered several parts, multiples of them, just to be sure, and also to have some of those parts in stock. And they came in very quickly. And today we're going to continue on with the video from that point. Okay, so I've got my parts already. These parts came in from DigiKey overnight. And I've got the diodes, I think it's D601. I'm going to install that and we'll do some testing on it. Of course, polarity is important, that we get in the right way around. The stripe on the end of the component has to match the silk screening on the board. This is not cooperating very well. So I'll take off the wires. That'll make it a lot easier. Those 2 wires I removed are actually the 324 volts from the EMI section that has a bridge rectifier in it. Okay, I'm going to put a little bit of solder flux on here. Probably isn't really necessary in this case, but I just find that it gets rid of the oxidization much better. Ensures our solder joint is good and reliable. I'm going to inspect that with solder joints just to make sure they have a nice conical shape and they're bright colored. If you're new to soldering and so on, the solder joint needs to be smooth, it needs to be shiny. If it's kind of got a non-shiny surface, that could mean that it's a poor solder joint. This little brush here that I'm using is a really nice brush for cleaning these boards. But it's also extremely expensive. Solder equipment and solder tips and stuff is not cheap. Okay. Visually, I don't see any problems. I'm going to put these wires back on. I'm going to put one screw in here just so that it holds it in place. Okay, I'm going to check my 324 volts first, and let's hope that we have no disasters here. There's my 325 volts. Now let's see if we've got any voltages on this output. I see no smoke or any sign that anything's going wrong here, so I'm hoping for the best. No, it doesn't look good. The 15 volts seems to be at still about 1.3 volts. And minus 15 is minus 1.2. So at this point it was clear that D607, the Schottky rectifier, was not the source of the problem, even though it was clear that it was shorted and needed to be replaced. When I measured the output of the aux board, it was not there. There was no voltages there. So I decided that the next step would be to change out the MOSFET. I did that partly because in the Lens Projects information, the MOSFET had been the problem quite often, and he had found that needed to be changed. And I've seen that kind of thing happen before. It's sort of the key central component that enables the switching regulator to work. So that was my next step. I decided to change out the MOSFET. This MOSFET is a TO3 package, and it's mounted on a vertical heatsink and has a screw holding it in. There's a transformer right in the road there, so that makes it somewhat difficult to get out. I ended up having to take a small screwdriver bit and cut it off shorter so that I could get it in there and remove the screw from the side of the heatsink so I could get that component out. I had to desolder the component on the bottom side of the board first. Didn't get all that on camera, but once I got the screw loose, then I was able to use these bent forceps to take the screw out, and I was able to get the MOSFET out. So there's the MOSFET. You'll notice it's got heatsink compound on there. For those of you who are maybe new to this, that's basically just a silicone material that allows or enables the heat to transfer from the device to the heatsink better. It gives it a lower coefficient of heat transfer, or is that higher? Anyway, that improves the heat transfer so that you can dissipate the heat in the heatsink. So I have new devices, and what I'm going to do first is I'm going to form the leads on the new one so that they look similar to the old one, and then I'm going to install that. I'll also add heatsink compound. The middle leg on this has to be bent out a little bit to fit onto the board. That should be pretty close right there. And then I'll take I have some heatsink compound, and I'll apply a little bit of that to the back of this. You don't see this as much these days as we used to. You can now get silicone material that can do this job, and it's less messy. I think I might have some. I could replace this with that, but I'm going to keep it the way it was. I'll show you an example of the kind that is used more often today. I've got that placed. When I took this screw out, it had a little lock washer on it, and the lock washer broke. So I'm going to try and find another lock washer of that size, because it is important that this be tight and stay tight. I wasn't able to find a lock washer exactly that size, so I'm going to have to put it back together without that for now. And what I'll do is I'll add some Loctite or some other kind of a glue later that will hold that screw from ever coming loose. Resolder that device in. I'll clip off the leads a little bit. Don't want them sticking down far enough that they contact the chassis. Flux isn't going to cause a problem typically, but sometimes the flux, if you leave a bunch of flux on the board, will obscure maybe little solder bridges, solder splashes that you accidentally left during soldering, so it's good to clean them up. Here's one of those silicone fabrics that you can put on instead of the heatsink compound. Don't know too much about these, but they you see them more often nowadays. Okay, so I have replaced the MOSFET, and we're going to try again. Just see if that is going to solve our problem. There's my 320 volts. Let's see if we've got anything on the output. No. That is disappointing. Ironically, when I first looked at this, I noticed that D601 down in here was somewhat discolored it, but I tested it with my meter, and with a simple diode check, it actually showed good. So anyways, after changing the first diode and changing the MOSFET, I decided that the next most likely one was probably this diode D601 down here. And so I changed that out, and when I did and powered it up, I was able to get voltages on the terminal strip over here. Just to give you a little bit more information on it. So that first diode that I changed was actually D7, which was this one, which is in the minus 15 volt supply. And it was shorted, and I don't know why. So I changed that out, didn't help. So then I changed out the MOSFET, which is located right here, and that's on the input side of the transformer, and that did not help. The diode that got it working was D601, which is this one right here. So we won't put it completely back together, we'll just hook up the input circuitry and so on and just make sure that it's going to operate. Okay, well, here goes. I have reconnected all the cables with this thing still open, and hopefully everything is connected correctly. 315 volts. Okay, now I'm going to try those other voltages. 15 volts, minus 15 volts, 3.3 volts that's supposed to be, 5 volts, and this should be 24 volts. Okay, those voltages all are looking good. Now, just a little bit of a visual. I'm going to look behind here and see whether or not my power LED is green. Got a flashing LED on the board there. I'm not sure exactly what that LED is for. But so far, so good. Okay. The next step will be to put the cover back on this, tie wrap the cables back into their places, so everything's neat and tidy, and reassemble this base unit. I decided before I put it back together I better check one more thing, and that was the plus minus 27 volt supplies. And there's actually two of them. They're located here, and so the connectors for those come from these two boards over to the power amp boards here, and I measured them on the connectors going into the power amp board, and got 27 volts on the positive side and minus 27 volts on the negative side on that one. And again, -27 volts on that one, and minus 27 volts on that one. So those supplies are working as well. Okay, so here's the Bose L1 stick sound system all put back together. I had quite a time getting the whole thing in the shot because it is tall. It's about 7 feet tall. No, I guess it wouldn't be quite 7, but 6.5 feet tall. I'm a little over 6 feet. So that's how high this thing is, and the speakers come in two pieces. This is one section of the speaker, and then this is the other section, and then it plugs straight into the base there. So we did finally prevail. We got the thing working. I ended up changing 3 components. One was a Schottky diode, another one was the MOSFET, but I think the real culprit, maybe the original source of the problem, was just another diode D601, which is in the circuitry for the MOSFET. Still, the other diode was shorted, so there was at least 2 components, and as far as I can tell, the MOSFET may be okay, but I replaced it anyway. So I put the thing back together. I applied a signal to all 4 of the inputs. There are 2 mic slash quarter-inch inputs, and there are 2 line inputs. And I tried all 4 of those, and they all work. There may be other functions on here that I'm not familiar with that I haven't tested totally, but I believe everything is working well. I have a few more screws to put in the base, and then I believe we are ready to get this back to the customer. So I'm chalking that up as a win, and I'm pretty happy that we didn't have any disasters along the way, and everything seemed to come together in the end. But I will say that again, this was quite a learning experience. One thing I learned was that sometimes you have to kind of go with your gut. That first diode probably should have been changed right off the bat. But I still would have found the other diode shorted, so at least those two parts were definitely faulty. The other thing I'm learning more as I go about switching power supplies. One thing I would like to know is whether or not there are better troubleshooting techniques for switching power supplies, because as I said before, the nature of the cyclic part of the circuit, where you are sending feedback from the output back to the input, makes it very difficult to do a conventional kind of signal tracing or troubleshooting. And if anybody's got some tips and pointers on that, I'd be glad to hear them. I've studied a few things online on YouTube about this, and there's lots of people will explain how a switching power supply works, but there aren't as many people that will actually give you concrete troubleshooting techniques that you can use to track down to the component level. Anyways, I think that wraps this one up. Thanks for tuning in. Would appreciate any comments you might have. Feel free to subscribe, and look forward to getting another one of these out to you fairly soon. I've got 2 or 3 other projects on the go, and I guess that's it for now. Thank you.